Hello everybody and welcome to this hopefully short, sweet, and concise tutorial on how to use open computers to automate immersive railroading trains, and specifically to have those trains arrive at a platform, stop, wait for an X amount of time, and depart all on their own using three programs that I wrote, and I will be sharing the code from those programs with you and going over how you can customize that code to suit your needs. Quickly, I just want to put a disclaimer in the beginning of this tutorial. I by no means am some professional programming man who this is the end all be all on how to automate trains. This is just simply how I did it, and I know there's better ways. I know there's most likely much better ways, but I am just showing the people who have been asking me how I did it. If you guys are curious to see how the code is running in my actual video where I created it to serve a passenger train loop, then I will pop the video up on screen right here. And if not, then just keep watching the tutorial and you'll be able to do it all on your own in your own world. So in order to do this, you're obviously going to need a computer. To set up a computer with open computers, I'm not going to go in super depth, but I'm going to give you a basic explanation just right here. You need a computer case, and within the same tier, you need a graphics card, you need a hard disk drive, you need memory, which I would recommend more memory the better if you're going to be making programs, and then you need a CPU, which is associated with the tier of the computer. Lastly, what you need is you need OpenOS, which is the operating system, and then you need this EEPROM Luau BIOS. To get this computer to actually show you things, you're going to need to place a screen by shift clicking and placing the screen. You're going to need to place a keyboard. And lastly, using your favorite mod, you can place an energy source like this fine coal power generator, and then your computer should be able to click on and it should start working just like this. As you can see, when you first fire up your computer, you're going to notice that your directory is read-only. You're going to have to install OpenOS by simply typing install and then typing Y to install OpenOS onto your computer. This basically allows you to use Luau on the computer. As you can see, once the installation is complete, it asks you to reboot. You simply press Y, you hit enter, and then you reboot your computer, and now you're able to actually start programming. We're going to be working out of the home directory. If you want to place your code somewhere else, you can look into how to change directories in Open Computers. Really quickly, I'm going to teach you how to edit programs and write programs within the computer. If you want to create a program, you simply type edit and then whatever the program's name you want, so we can write test. As you can see in the bottom, it says test new file, which implies that this is a new program. Let's simply write print, open bracket, quotations, test, worked, close the quotes, close the bracket. At the bottom you can see there's many options. The most important options are going to be Control S to save the program and Control W to exit. If we click Control S, we save the program, and if we hit Control W, we're back to the home directory. Now if we write test, it runs the program, and by running the program, we now know that the syntax and everything associated with the program worked, and now we are ready to move on to the next step, which is actually going through my code and my programs and helping you get those working on your systems and in your worlds. Okay, so before we pull up the blueprint, so it's easier to talk about this without me running around all over the place, I want to show you how you can set up open computers to actually detect the immersive railroading augments. What you need is adapters and redstone IOs. When you place a locomotive control augment on the tracks, you can remove it by right-clicking it with the immersive railroading wrench. You need to place a adapter underneath the locomotive controls and connect it to the computer using an open computer's cable. And with the analyzer, if you shift and right click, the analyzer will tell you the address of the adapter, which is then associated with the immersive railroading augment. As you can see, when it comes to redstone detectors, it's the same thing, but instead of an adapter, you need a redstone IO, and if you shift right click it, it tells you the address of the redstone IO. So going to the blueprint now, as you guys can see on screen, I've made you a graphic so I'm not running around and confusing everybody. We were standing way down here, and let's start this whole thing at the beginning. So, as you guys can see, the station is indicated by this yellow line. The train approaches from this side. The distances here are shown. So, we have one augment here, locomotive control, which is controlled by an adapter, and that is known as plate in the code. So when you guys are setting this up yourselves, this address in the top of the code for plate, you're going to have to change to what your registered address is for this specific um, adapter and IR augment. Then you have red 1, which is a redstone detector with a redstone IO, and this right here is the association in the code for mine. And again, you will change this number to what your analyzer says. Then for the actual physical building, we have a distance of 46 blocks between the station beginning and red 1. Then the station itself is 73 blocks. Then we have a distance of 10 blocks from the end of the station to home plate. Home plate is another locomotive control with an adapter, and this would be the address that I have, and you would be changing yours to the address that you have for this adapter and augment. Then followed by this, you have red 2, which is the second redstone detector with this address. Then we have 7 blocks of distance between red 2 and plate 3. And lastly, plate 3 is the third locomotive control with the adapter address of this in the code. So when we look at the code, you'll notice that at the top for my variables and my registered addresses, I only wrote the beginnings of these addresses. Since they're different, you can get away with writing only the initial numbers or letters in the whole address. You do not have to write the whole thing. It's probably better if you do, but you can get away with this. And when you're changing the code to run with your specific adapters, you can come here and see which adapter and which IO adapter are registered to which address, and then you can change them with reference to where mine are located to where you place yours. Okay, so here comes the nitty-gritty code explanation. Looking at the blueprints side by side with this code, let's start with train arrival, I called it. Up here we just have some arguments that let you use things like component.proxy and component.get, and then sides simply is something that lets me dictate with the redstone IO if the top or the bottom or the left side or the right side has a redstone input. These you need to place if you want to have code that works with immersive railroading and open computers. Right here are all my variables that I have stated. All that this is saying is that I've named plate is essentially associated with this address, home plate is associated with this address, and so forth. So as you guys can see in the blueprint, it is very important for you to have the analyzer to see what the address of your adapters and redstone IOs are, and then simply place them into here instead of copying these, because these are associated with mine and your addresses are most likely going to be different. Then, as the train is coming in, we're going to have a simple statement of print running arrival. All this is to tell me on the screen that arrival program is basically running. I have plate set throttle to 0. What this does is it sets the locomotive's throttle to 0, and now the locomotive is coasting into the station under its own inertia. Then I have print throttle set to 0, just again to reinforce visually a printout that will say the throttle has been set to 0. I have os.sleep 0.2, so that's 0.2 seconds. I have the code simply stop and not do anything for 0.2 seconds. The reason you need to use os.sleep is because if you simply use just sleep, your program, I found, will run out of memory and will crash, and it will just not work as consistently and efficiently as you'd like. So simply using os.sleep solves all your problems. Then I have plate.setBreak to this value. 0 is 0 break, 1 is 100% break. These values you can play with based off of how heavy your train is, and I emphasize that because The weight of your train will dictate the acceleration and the stopping distance, and that is why my disclaimer in the beginning was that this is not the best way to do it, because if your train burns fuel over time, it becomes lighter and it stops a bit further because it picks up more speed when it's departing. I got around this problem a bit because, as you can see, I have home plate and plate 3, which basically do the same thing, but they are like a mechanical way to physically allow the train to still get inputs even if it overshoots its stopping point. Continuing, we have print brake applied, which simply now is printing out that, hey, the brake has been applied. I can look at the screen and see the brake has been applied, and I know up to this point the code has worked. Then I have it sleep for 0.2 seconds. I have it hit the horn, and then I have another sleep, and then I have it plate.bell, which simply means that now the train is going to honk its horn. 0.2 seconds are going to go by, the bell will go on, and then I sleep it again, and I print arrival completed, which tells me now that the train has received all these instructions, the program has worked up to this point, and everything so far is going well. Now, down here is a loop that I start with redstone 2, the IO that you can see on the blueprint, red 2. What this statement tells you is if red 2 gets an input on the top that's greater than 0, which implies that the detector above it has detected a train and given the redstone IO a signal that, hey, there's a train up here, which is emphasized by greater than 0, then homeplate.setBrake is 1. Homeplate is way down at the end, which now that the train is coasting into the platform under 0 throttle but 0 brake, it's hopefully slowed down just enough that when it hits home plate and puts 100% brake on, it will now stop relatively close to home plate. Then I have it sleep and I have it brake. Basically, this is just that if this was true, it does these things and then it breaks the loop. But let's say the train has not arrived over red 2 yet, and the value is not greater than 0 because there's no redstone signal. The code skips all this and it goes to the else statement, which then I have it print waiting for train to stop, and I have it set to a 0.2 second timer. I also add an end command and then another print, just because when you're printing this, if you don't have this down here, it'll keep printing this, but once the screen fills up with this, you don't really know if it keeps printing a new line. So what I did is I put these two in here just to simply get some variation in the screen printing so that you can tell the code is still working and it basically doesn't look like it froze. Now, let's say the train, like we said, is on top of red 2. Red 2 gives an input which is greater than 0. Home plate sets the brake and it breaks the loop. Now we're out here. The train now at this point will have applied full brake, hopefully stopped on home plate, and it's going to start counting a timer. I have a 60-second timer, which means that I print, for example, departing in 60 seconds. I have os.sleep for 10 seconds. Then I print, obviously, there's only 50 seconds remaining. I print again os.sleep, which is another 10 seconds. And again, this is a crude timer I make just to count 60 seconds in order to let the train sit at the station, and let's say you're running up and whatnot, you have a whole minute of the train stopped at the station. You can change all these values to make the train stop longer or stop shorter at your station. You also don't need these printouts, but I find that it's pretty nice because the computer screen will be counting down essentially every 10 seconds and showing you an updated time count before the train leaves. Now, at the very end, we have simply print train is departing. At this point, you know the code has ran all this way successfully and the train is beginning to depart. Now, very importantly, at the bottom, we have os.execute. And what this does is, whatever you have in here, it's going to now execute this program. And by that I mean, when one of these programs runs, either train departure, train arrival, or shell program, it loops all these programs continuously. So you will never have to type one of these programs in again unless you break the program loop. Now let's take a look at train departure. Your train has arrived into the station, and now we want it to depart. So again, at the top, I have my arguments which let me use things that can then later on make my variables associate with the specific addresses of the adapters and the I/O adapters. In this case, train departure only relies on home plate and plate 3 to be associated with this program, so that is why I only have home plate and plate 3 at the top here. Again, when you're making this program work for you, you're going to have to use your analyzer and change these addresses to whatever addresses you have at the locations given on the blueprint image I have posted. Now, gpu.component.gpu and gpu.setResolution is simply me saying that, hey, when train departure runs, because I have screens at my train platform, you can see how the resolution is super tiny. This makes it so that the resolution is big and I can read it from the platform, and all that helps me see is when I see the 60 seconds remaining, 50 seconds remaining, you can actually read it from the platform. Without this, you would just see these very small lines and it would be pretty difficult to see. Now, continuing with train departure, as you can see, I write executing train departure, so I know up to this point the code has ran. I sleep 1 second, we have home plate fire the horn once, then we sleep 1 second, we have the home plate fire a horn twice, we sleep 1 second, I disable the bell because on the train arrival program we have the bell value set to 1, which turns it on, and when the train is departing I want it to turn the bell off. I only want the bell when the train is coming into the station. If you want the bell the whole time, you could just change this to 1, or in train arrival you could just leave it at 1 and not change it back to 0 here, and the bell will be going the whole time the train is driving forever. Next I have its sleep 0.2 seconds, then I print departure is working. Home plate sets the brake to 0 because, as you saw earlier with train arrival, we have home plate set brake to 1, which is 100%, and now we set the brake to 0, which is no brake. We wait 1 second, then we set the throttle to 0.75 on both home plate and plate 3. This is important. The reason I have home plate and plate 3 is not only for stopping the train, but this gives you a cheaty way to account for the error of your train stopping. And what I mentioned earlier was, if the train is lighter as it burns fuel, it will stop further and further from home plate. I'm not talking about large distances, but maybe half a block, and then 1.5 blocks further than you anticipate. What this lets the train do on departure is that home plate sets the throttle to 0.75, which is quite aggressive. You'll notice that the train picks up speed and accelerates rapidly. We wait 4.2 seconds, and the train is still set to 0.75. 4.2 seconds later, I hope that the locomotive is still, it's certainly not going to be over home plate anymore, but it's going to be over plate 3. And by having it set both plate 3 and home plate to 0.31, it essentially tells the train, hey, stop accelerating like crazy. Let's set it to a value, which again, you can set this value to whatever you'd like. This value I found roughly makes the train go 30 kilometers an hour. And then because the train is now completely over home plate, if I had just set it home plate to this, the train wouldn't respond because it's no longer over home plate. So I have it set plate 3 as well to this throttle, which is why you see when the train departs, the black smoke from the 0.75 acceleration, and then the 0.31 or the 0.31, I guess, acceleration or deceleration in this case occurs once the train is 4 seconds past home plate essentially. I know this is very confusing, but this is the best way I can explain this. Now, after the throttle is set, I have os.sleep0, which is, I guess you don't really need that. I don't know why I have that in there. I guess I don't, you actually don't need that in there. Then I have it print that train departure ran successfully, which is, again, just me reiterating that, hey, the code has ran up to this point without issue, and yeah, that it's running perfectly fine. 1 second after this statement, I have it print, train will be here in approximately 6 minutes. Now, when I made this loop, this is the loop that the train follows. I timed it, and roughly, when it stops at all these stations, it takes around 6 minutes for the train to complete the loop. So that's why I have it say train will be here in approximately 6 minutes. I sleep for 1 minute. I write train will be approximately here in 5 minutes. You sleep again. It's again another crude timer. Once it does roughly this 4 minutes, at train will be here in approximately 2 minutes. I have it only sleep 5 seconds, and no longer does it print out a time like this, but it begins the scan program, which I called shell program. Okay, and as you can see at the bottom here, I print starting scan program and os.execute shell program begins, which is how you start another program within a program. I have os.sleep1 down here, and again, I'm pretty sure you don't need this, but I just had it so that just in case I'm not running out of memory when I'm basically running these programs. Now let's talk about the scan program, aka shell program. So, shell program is simply a program. When looking at the blueprint, you can see this is how I start to detect after the static 6 minutes timer after the train departure program. This is what starts to run on the redstone detector during the train arrival. The reason I don't have this program running constantly in the background is just to reduce the workload on the server and the computer. If you want, you could probably run this right after your train departs, but this is a loop program and it's just going to, on the screen, keep writing what I have here instead of the train will be here in 5 minutes, the train will be here in 4 minutes, and so forth. Again, at the top, you have to have your arguments in order to make your variables actually associate with the analyzer given addresses of your, in this case, your address for plate 3, and in this case, your IO address for redstone 1. Now, as you can see, this program is just a simple loop. While true, which means that when this program is run by os.execute shell program after the train departure, um, it starts to run a loop. So if red1 gets a redstone input of greater than 0, which means that, again, the detector above it has detected a train, and it gives it, obviously, a value of greater than 0, then I print train found, which implies that the train is now on top of red1. When this occurs, os.execute train arrival starts, and it breaks the loop, which means that, oh, now the train is actually at red 1, so we don't have to keep scanning for it because we know it's here now, and let's run the train arrival program, which we've already gone over. Okay, now, if the train is not over the redstone IO and has not been detected by the redstone augment, it simply skips down here to the else statement and prints scanning no trains found. I have it sleep for 0.2 seconds, and then here I have it print a dashed line, and I have it sleep for 0 seconds. So all this does is it goes, there's no train above it because this isn't greater than 0. It goes down here, it goes scanning trains, 0.2 seconds, gives me a line to break up again, not just writing no train found, no train found, and then once it fills your screen, it looks like nothing's moving. Here, at least, by writing the two different lines, you can break it up and see if the program is moving appropriately or if it's crashed or frozen or whatnot. It just helps peace of mind for me and makes me visually understand, yes, the program is still working. I know you can definitely get away with not having this, but then like I said, your computer screen will just fill up with one line and you won't know necessarily if it's still running okay or maybe something hung up, or it's just something that I like for peace of mind. Okay guys, so the final part of this is how do you add the code without having to retype it all into your open computers. This is pretty simple. Once you download the programs from GitHub, you go to your %app data folder, you go to roaming, your .minecraft, and then in your .minecraft you find the world that you'd like to place the code into. So you simply go to the saves if it's single player, or on a server you would just find the world folder, and then you go to the world that you have the computer in. You go to open computers, and then a really weird file name is actually the ID for computers. So if you have multiple computers, you'll have multiple different files like this, but for example in this tutorial world I only have one. You go in here and then you just go to the directory that we made our program in, which is home. And right here you'll find you can dump your files into, and then when you run the game, you should have train departure, train arrival, and shell prog. And lastly, I just want to show you guys what you're going to be editing. Again, just a really quick breakdown. So up here, you're going to be editing these IDs for all of your guys' adapters that you will find with the analyzer, like I said. You're going to want to change this value for braking, because when the train is coasting into the platform, depending on how heavy your train is or what you are doing with your train, you can change this number to make it come into the platform slower or faster. Obviously, if you make this too high and it stops before home plate and red 2, well then you're gonna have just issues because your train didn't coast long enough. And then finally, what you want to do is in train departure, you're going to want to probably edit your throttle for accelerating out of the station, and then maybe the time that it took between changing this throttle back to a reasonable throttle to have the train coast. But yeah, I hope this tutorial helped you guys. I promise you, I tried to make it as not confusing as possible, but I mean, I am not a master at describing programs in general because it took me a while to figure out how to make all of this. But yeah, feel free to throw any questions in the comments. I'll try to answer everything. Please be nice. I hope this really helped you guys. I hope you guys are able to automate your trains somewhat. And like I said, if you have any questions, feel free to leave them in the comments. And yeah, thank you for watching this one, and I will see you guys in another video.